Hey everyone, welcome back to the channel. So in this video, we are going to solve the Leetcode problem 2081. So we have this problem in today's contest problem in the daily Leetcode problem solving series, right? So let's continue and understand that, right? So just think that what if I told you some numbers look like a mirror, right? Not just the base 10, right? But even in the base 2, base 3, right? We have, and we can go much in deep right today. So let's understand and let's solve today this Leetcode problem 2081, the sum of k mirror numbers, and we'll do the code in Java. Okay, so let's continue to understand what is the problem is saying that. Okay, so the problem statement is saying that we have a k mirror numbers, that is a positive integers, right? Means we have a k mirror number and it is a number that is a palindrome in base 10, right? What does it mean? That I will explain you much better, right? Just think that what we have given a k mirror number that is a positive integer, right? So don't think without leading zero these things. Just think that we have given a k mirror number in the positive integers without leading the zero, means we can see forward and backward in base 10. It means we have given this k number, right? Let's suppose we'll call k equal to 2, right? So we have given k equal to 2, means k mirror number we have given, right? And it is a number that is a palindrome in base 10, right? Base 10 we can say. What we have given in the base 10, as you can see, k equal to 2 means that is in the base 10, and also it is also a palindrome in base k, right? Base k. So what is k we have given? 2. So we can say base 2, right? So the number that is we have given is, we can say, in the base 10, and it is also palindrome in base k. Understand? I'll go through much deeper, don't worry, just understand. So first of all, if you are not aware with what is base 10, think what is the base 10. So base 10 is a normal number system, you can say, that uses from 0 to 9, correct? So if we are using the digits from 0 to 9, means that is our normal number system, right? You know the number system, right? That is number system, correct? And so from 0 to 9 is the digit that we will use, that we are using in the number system, right? That we are using. Also it is called you can say decimal system. You're also saying the number system, or you can also say decimal system, right? For example, let's suppose I'll take 254, right? If this is a number, right? So we can say this is in the what? Base 10. It means how? It means what? If we'll take 2 into what? 100, what become 200, plus if I'll take 5 into 10 plus what we can say 4 into 1. So what will become it? It will become 254. Means this is 250 and 4. So this is become what? 254. And that is why we can say this is a number system. We can also say it's a decimal system. Understand? So just think that what is the base 10? Base 10 is nothing but our number system thing, right? Now think what is let's suppose base 2. What is base 2? So base 2 is let's suppose a binary system, right? You know the binary number system. So this is a binary number system, right? So let's suppose for every digit that we will represent in here is what? Power of 2. Power of 2, right? We will use the power of 2. We'll take 2 and there will be some power, right? This number, that is, we can take x or y and g, anything, right? So for example, let's suppose we have to convert what? 9 from base 10 to base 2, right? This is the base 9 and we want to convert into base 2. Then what we will do? Let me clean it. Okay, sorry. So let's suppose we have to convert 9 we have to convert into base 2, right? And this is in where? In the base 10, right? This is in the base 10, right? So what we will say, if it is in the base 10 and we want to convert into base 2, what we need to do, right? Just think, from base 10 to base 2, right? If we want to convert it, what needs to do? Let's suppose first of all we have 9. We'll divide 9 by what? 2, let's suppose, right? What will come remainder? It will come 4, right? This is our nothing but remainder, right? This is nothing but a remainder, and remainder is coming what? 9 by 2. If we'll do, right, what will come? Remainder will come here 1, and that is our LSB, we can say, right? LSB means least significant bit, right? What is the least significant bit? Is 1. Now think about the, now we have 4, right? We'll take the 4. What will come here? It will come 2, and so remainder is what? 0. So this time LSB is what? Least significant bit is nothing but 0. Now we'll take 2. 2 by what? It will come 1, right? 2 by 2, sorry, 2 by 2. What will come? It will come this time 1, right? And the remainder is nothing but 0. Now we'll take 1 by 2. What will come? 0. And this is so this time remainder is what? We can say 1, right? This time 1. It means this is your most significant bit, MSB. This is the most significant bit, right? So we can say 9 in base 2 is what? 1 0 0 1, right? We have taken 1 0 0, and this is 1 here, 1. So it will become what? What it will become? 1 0 0 1, right? Like that it will become, right? So if we'll consider, let's suppose, let me clean it. Let's suppose if we want to take some base 10, right? Let's suppose from base 10, if we want to convert into what? Base 2, right? Means this is nothing but a number system, and this is nothing but what? Binary, another binary number system, right? So for 1, what will become? Base 2 is 1. If we'll take 2, the base 2 will become what? 1 0. If we'll take 3, the base will become what? 1 1. If we'll take 4, it will become 1 1 0 0. And if we'll take 5, it will become what? 1 0 1, right? Like that we will go, right? I think there is also a formula, I forget that, 8 4 2 1, I think. Let's put this value. If I have the number 1, so we'll take what? This is enable, this is 1, and rest of the thing is 0 0, right? 3. Let's suppose this time we are going for the 2, right? So we come 2 is what? This one will be enable, rest of the thing is 0 0, right? Yeah. And then if it is what? 3, we can say 2 and 1 is 3, rest of the thing is 0 0. So like that, if you'll take, you know, the binary system will calculate it, right? This is the trick that we used to remember in the college, right? So 8 4 2 1 we'll say, and we'll calculate the base 2 binary system. Understand? So now understand the example that we have given, right? Right? You can pause this video, you can go through this, right? So what is the example is saying that here? Means let's suppose you gone through the statement, right? And we have to return the sum of n smallest k mirror number, right? What is the mirror number? That we'll understand. Just think that we have given n equal to 5. What we have given? N equal to 5 we have given, right? Means we want the first 5 number that are palindrome in both base 10 and base 2, that we have already seen, right? Means if we'll talk about 1 and 1, it will become what? 1. 2 will become what? 10. 3 will become what? 1 1, right? 8 4 2 1. You write the 8 4 2 1, so you will remember, right? Then 4 will be there, right? 1 0 0. Then 5 will be there, 1 0 1, right? Like that. So this is your base 10 and binary number system, right? Means this is base 10 and this is base 2, right? Base 10 and base 2, right? We can say. So we want the first 5 number and that are the palindrome in base 10 and 2, right? So is, let's suppose if we are going to check the palindrome is there or not, right? So let's suppose we'll go for the first one, right? So this is what? The base 10, right? And this is what? In base 2. So is the palindrome in base 10, right? So this is in the base 10, right? This is the base 10, palindrome is there, right? It is. If is this palindrome in base 2? right? This is right, this is also there, right? But this is, we have, this is in the base 10, means we have base 10 the palindrome. I'm talking about the palindrome. Then I'll talk the example again. Okay, so we are checking the palindrome in base 10 and base 2 each value, like that. Keep going there and check, right? So this is not in the base 10, base 2, this is in the base 10, and this is in the base 2, so it is also correct, right? This is in the base 10, but this is not there, right? This is not there. You check this one, 5, yes, both are there, right? So first we got what, 1, then we got 3, then we got what, 5. Like that we can get more, right? Let's suppose we'll get 5, then we can check 6 is there, so 2 and 1. So like that we have, means we have to calculate like this. Let's suppose we'll calculate, you will calculate all of them, right? So what you will understand, you will convert the base 10 and base 2, and you will have the representation both, right? And you will check the palindrome in base 10 and base 2. If both are palindrome in their number system, right, then we'll say these number, let's suppose for this number that is already in the palindrome in the both cases, in the base 10 and base 2, is a k-mirror. Yes, it's a k-mirror, it's a k-mirror, it's a k-mirror, that is called k-mirror. But we have to check for the k should be there, k should be given there, right? So let's suppose I'll just will think that we have given in the base 10 we have given here, and base 2 we have given, right? If you do the sum, so 1, 3, 5, 7 and 9, these are the number is palindrome in both cases, right? If all are in the both cases, we will get what, 25, right? What are the numbers are there? Number was 1, 3, 5, 7 and 9. So these numbers are palindrome in both number system, in the base 10 as well as the base 2, right? And so if we'll do the sum of all these numbers, we will get the answer. Understand? So what we need to do, we have to find the sum of n smallest k-mirror number, and this is the number system we have to find, and this is the question is saying that, right? If you pause this video, go through the statement, you will understand clearly. Understood? So now we can say that we can have our intuition, or you can say the approach, right? Let's understand what is our intuition. Let me change the color, right? Just think that what is the intuition we have, right? And approach, you can say, right? What is the intuition and approach? Means first of all, we have given what, k-mirror number we have given, right? So the you can say a k-mirror number is a number that is palindrome in both cases, in base 10 and base 2. If it is this number, if this number is palindrome in both cases, is palindrome in both cases, right? In base 10 and base k, right? That is not 2, we can say k, right? In the base 10 and base k. If in both cases, if it is what, palindrome, then we have to find those palindrome numbers and we have to make the sum as we have seen here, right? So first of all, in the very first step, what we should do, right? We will generate the palindrome number in base 10, right? What we will do, generate all the palindrome numbers, right? We'll generate all the palindrome numbers in what, in base 10. We can do that, right? Because we have to go from the smallest to the largest, right? Means we have to go from the smallest to largest, right? And so that we have to generate first what, all the palindrome number that is in the base 10, right? Then what we should do, we should go for converting into k base, right? Means all the number that we have generated, right? Means for each one, you can say for each one that we have generated, will convert it into what, base k, right? We'll convert into the base k. So we have to convert into base k. Understand? Then what we should do, once we have converted, then we'll check if the base k representation is also palindrome. Then we'll check if the k representation, base k representation, if base k representation is also palindrome. If it is also palindrome, it means what? We will include this into the result, right? So that will convert into save in the result, save in result. Otherwise, discard it or stop it when we have found the n numbers, right? That we can do, right? Means once you find that number, converted number is also palindrome, so we will include into the result, right? And once we found all the n numbers, right, then we will stop it, right? So let's continue to understand the code. So let's understand the code. Okay, let me increase it. Okay, so as you can see, right, what we need to do, we have given k, we have given, and n we have given, right? Means we have to define sum of them, right? Let's suppose we have to find the sum and we have to return this sum, correct? So we'll define the sum here and we'll return this sum once the sum is calculated. Means all those number that is palindrome in both base 10 and base k is there, then we'll make the sum of all those palindrome numbers, right? So first of all, what we need to do, we will make a while loop, and we'll continue until we find the n kth number, right? K meter number will not find. Until that we will continue. Means count should be less than n. If the count is exceeding more than n, it means we should stop it, right? Then we'll generate all the palindrome base 10 number of the given number, right? So we'll take a for loop, right, like this, and we'll continue till here, right? We'll take the power of 10, and then you know the math.power, right? That function will use, and you will write like this, and then this for loop we will continue, right? Then we will check all its length, right? How we're going to check? We'll create a full palindrome number from the left half. You will just use, we will create another function that will call the create palindrome, and we will pass these values. We will pass. We will do try run, then we'll understand. Don't worry. So first of all, what we'll do, we'll continue this loop, while loop, until it not reaches to the n numbers, right? Count is not reaches to the n, not exceeding the n. Till that we will continue. Then we'll generate all the palindromic number that is in the base 10, and then we'll create a full palindrome number using the left half, and then we'll check if the number is a palindrome in the base case. Then we'll check if it is, then we'll increment the count. We'll say count plus plus, and we'll add that number into the sum. Once these all number is we found these numbers are mirror, we have the count, and we'll increment we have the sum, and we'll return the sum finally, right? So what is the is sum is there, is mirror is there, you know how to find the palindrome, right? So to create the palindrome, you will create this method. To check the is mirror method, you will use this method, and there is a base k method, so you will use the base k method. Means you just take all the reminders, keep taking the reminders, and you will get it, right? So we'll understand this thing also. Just think that we'll use this one, and then another is palindrome method is there, so we'll use this is palindrome method in the is mirror method. Okay, so now let's understand the try run. So actually we should understand the core logic we have in the this mirror method, right? Is mirror method, right? So if we will start with the, let's suppose I, right? So I will start the loop length. Let's suppose we'll take I equal to what, 1 to 9, right? So we have to generate what? We have to generate all the we can say what? We have to generate all the one digit palindrome, right? So let's suppose when I equal to 1, right? When I equal to 1, in that case this create method will give what? It will give you, we are passing what? I equal to 1, right? And this will give you what? True. The length is true, right? If we will divide, right, then what we will get? We'll get true here, right? So we'll get create palindrome of 1 and true. So this function will return you the nums what will come it? 1, correct? So now we will check into the mirror. So mirror method will get what? 1, and k value will be, let's suppose 2, right? For the example one we are talking about. Okay, so what we will get here? 1 and 2, right? So if we'll talk about the number 1 and 2, let's suppose here, so the base 2 for 1 is what? 1 itself, right? And so we'll say this is palindrome, correct? So we'll, if this time the count will become what? 1, and the sum will become what? 1, right? So because num we have added, right? So we will check, will this check method, each mirror method will check what? 1 and 2, correct? And then we'll say this base 2 is 1, right? And then we'll get what? Palindrome, right? So base 2 of 1 is 1, and so we are getting the palindrome, this number. And then we will check what? Is mirror method will check, and then we'll get what? Sum will become 1, right? And then we'll count, come what? 1. Here sum, and this is 1 1. Okay, let's continue ahead. Now think when I equal to what? 2. When I was 1, sum was 1, and count was what? Also 1, right? Both was 1. Now I is equal to 2. In this time, what will happen? The nums will take as a what? 2, right? So let's suppose I equal to 2 means nums is 2, right? So this case, base if we'll take for the 2, right, nums, what will become? It will become 10, right? And it is not palindrome. The base 2 of this number is 10, right? So it is not palindrome, correct? And so we will discard it. So if we'll update our count after this, sum become what? 1, and count will become what? 1, correct? Now we'll increment I equal to how much? 3. So this, it means nums is what? 3. It was num was how much here? 2. Now it is what? 3, right? So if we'll take the base 2 of this number, what will come? It will come 11, that we have seen already, right? And it is palindrome. So we'll add this into the sum, right? So now sum will become what? 1 plus 3, and 1 plus 3 is what? 4. Now count will get incremented. Count is now 2. Now we'll find what? I will get increment, I equal to 4, right? When I equal to 4, so the nums become what? 100, right? And this is not palindrome, so we can discard it. Similarly, we'll check for what? I equal to 5. We'll check I equal to 5 is what? Base 10. If we'll take 5, it will become what? 101, and this is palindrome. So we'll add it. So this time 4 plus 5 is become what? 1. 4 plus 5 is become 9. So the sum will become what? 9, and count will become what? 3, right? Like that we have to keep updating all those values, right? Then we'll go for the 6. Let's suppose when 6 is there, then what is the number is there? 8421. Remember 8421, right? So here we become what? 101, right? So no, not 101, this one, sorry 110, but this is not palindrome. Then we'll check for 7. What will come? 7 for 111. This is palindrome, so we'll add this number. So 9 plus 7 will add, it is 15, right? Next check 8 is what? 1000, right? Use this formula. Then what will come? It will come what? We will not add this one, we'll go for 9. 9 is what? 8 and 1 means 1001, and this is what? Palindrome. So just add it. So 15 plus what will become 25. Like that we will 15 plus this 10, right, or 9. Okay, yeah, 6 it was, it should be 16, right, and then we'll get add 9, right, means 7 16, yes, 16, and this should be 9, right, yeah, then it will come 25, right, means we have to add like this and you will have our result, right, means this way we will do dry run and then we will understand. So now let's break it down the problem code, right, so you will understand the code, right. So first of all, the main method itself is nothing but what, k mirror, right, number. So when we'll call for the k mirror number, right, we'll have two things we have, right, we have k we have given and n we have given, that we have seen in the example, right, I'll show you. So this is the example we have already here, as you can see, k and n we have given, and so we have given these things, right. So let's understand the main method, how main method works, right. So first of all, this main method keeps generating the palindrome of increasing digits length, right, and so we are doing it here, right, this piece of for loop will do here, right. So it will create the palindrome and will check is this mirror or not. If this is mirror method, we'll say yes, it is mirror method, means we'll add into the sum. Understand? Means we'll keep generating the palindromes, right, we'll keep generating the palindromes of increasing digit length, and for each one, right, for each palindrome, it checks if it is palindrome in the base case, right, in base case, and that we will check in where is mirror method, right. So is mirror method will pass each generated palindrome, is it a k mirror, you know how to do the checking, right. So we'll check with respect to the base k. If it is, then it will keep count until it finds a n number, right, it will keep checking. I'll show you the is method. So I think I've already shown you. So this is the palindrome method, it will create the palindrome, and this will check the is mirror method, right, where we'll pass the number and you pass the k, means we have to find in the base k, we will check if the number is palindrome in the base k, right. So for that you have to take in the base k, this is a separate utility method that will give you the is it a what will the number will come in the base case, right, base k, that you will get. Further you will check if is this number is palindrome, if is this string is palindrome, right, and for that you will check to convert, you have to convert this method, and to check you have to check in this method, right. So to convert into base k, what you have to do, you have to call this function, you have to implement this function, right, and you know how the remainder works, right. You will take a string builder, then you will check all the numbers, right, if it is you know the to find the sum of all the sum of digit, you know the integer sum of all integer numbers, right. The same thing we will do here, right, we'll check that and we'll convert it into the sum, right. Then we'll check is palindrome method. Okay, how we are going to check the is palindrome method? Like this, right, if the left is less than right, and we'll check in all digit if it is palindrome, right, then we'll reduce left plus plus and right minus minus, right, and we'll say this is a palindrome number, right. Like that we'll keep checking all the numbers. Let's understand again. So first of all, what we have told you, that we will take this k mirror method, right. So this method will keep generating all the palindrome number, right, and we'll check each palindrome number in the k mirror. Is this a mirror number, right? For each number we'll check if it is a palindrome in base k. If it is, means let's keep it as a count plus plus and add all those numbers into the sum, right, because we have to find the n such numbers, and that is why we are taking the count, right. So that we'll check, the loop will keep checking until we have not find all the numbers, right. Understand? So now understand the create palindrome method, right, how this create palindrome method will work, right. So we are passing a half, this is nothing, I is nothing but what, half long, right, we're saying say long half, right, we'll take long half, and this is nothing but our odd length we can say, right? So two things we will pass. The first is half long and this is odd length, right? Means we want to build a full palindrome from the half number. Let's suppose we call it 1 to 1, right? We have 1 to 1 number will pass for the I. Okay, so we will not pass 1 to 1 in this number, right? What we are trying to find, we'll pass, let's suppose 1 to 1 we have, but we'll pass only half number is this 1 2, right? Means if we'll take half is what? 1 2, right? And we'll take equal to 1. If this odd is, if this is odd, we'll pass what? Let's suppose we'll say odd. Odd is what? True or false? So if it is odd, we'll say true. If it is not odd, we'll pass false, right? We'll pass true or false. So let's suppose the half is what? 1 2, and the odd is what? What is coming what? True. It means what? This will become what? It will return palindrome 1 to 1. It will return the palindrome is 1 to 1. Understand? It will return 1 to 1, this function. Next, let's suppose we have given what? Let's suppose we'll take half. This time is nothing but 12 itself, right? But the odd is coming what? Odd is false. In this case, it was returning what? 1 to 1. Now what it will return? It will return 1 2 2 1, right? So this function will create a palindrome, right? So to create a palindrome function, you have to create this function, right? Let's understand how this function works. So just understand how we are going to create this function, right? So this function is a create palindrome, right? Means we'll pass the half and the odd length we will pass, right? Means the purpose of this function to generate a full palindrome number in base 10 using this half number, right? Half of the number, right? We'll pass it and we'll generate the full palindrome number in base 10. Why we are doing this? Because instead of checking every number to see if it is palindrome, it will become slow, right? And so we will build only palindrome directly. So this will save the time. And so let us control how many digits we want, right? So that we'll go through this approach, right? Because this saves the times and it will also have the control over how many digits we want, right? This is also our control we have, right? So let's start from here. So we'll start building from the left half, right? And then we'll find our odd length by half, right? We'll check. So what we are trying to do here, let's just think that, like, first of all, we'll start building from the left half, then we'll remove the last digit to avoid repeating the middle digit, right? Then we'll check we'll add the, you can say, reverse digit here, so that we can move to the next digit here, right? And we'll keep doing these things so we can create the palindrome. So let's say the half we are passing here is 1 2 3, for example, and this we are passing what? True, correct? So if we will pass this thing 1 2 3 and true, what will happen, right? So we want to create, actually what we will create, we are passing 1 to 3, means we want to create what? It should return 1 2 3, then it should return what? The half of this, right? Not 2 and 3, right? 2 or 1, sorry, give me 1 second. It should come what? First 2, then 1, then it will become palindrome, right? So it will return like this, right? We want to create like, we want to return like this. We'll pass 1 2 3, but we should return, this function should create this palindrome like this, right? So we can save that time, right? So what we need to do first, let's start from here. Okay, so first of all, let's drop the half of this digit, right? So half of the digit is what? 1 2, right? So in the RES, what in RES we are doing what? We're dividing by 10, right? The half by 10, right? And then if it is true, if the odd length is true, then what we will do, we'll divide by 10 and you will get half of the digit, that is called 1 2, right? Now the real value was what? 1 2 3. Now we have half is 1 2, right? Means we will append the reverse to 122 res, right? So you have this half, just you have to append it, right? To append this, you will do appending here. If half is greater than 0, so you will multiply in the res into 10 and you will add into here, right? So what will happen here, you will get what? Res what? 123. Then we are multiplying with 10 and then we are passing what? Half is what? 1 2, half is 1 2, right? The res is 1 2 3, correct? Then res is 1 2 3, then we are multiplying by the 10, then we'll pass was half, we'll take the mod of 10, so it will become what? Mod of 10 is what? It will become 10, you can say, right? 10, right? Not 10, so 2, it will come 2, sorry, it's my mistake. Okay, if we'll take, let's suppose the half we have and mod we have, half is what? 2, and we have to take 10, what will come? It will come 2, right? So we have to pass here 2, correct? Means you have to multiply this and you have to add this. What you will get? 1 2 1 2 3 2, 1 2 3 2 we will get, right? Now we have to, again we have to divide the half. From half we'll take, if we'll divide 1 2 become 1, so half is now 1, right? Once half is this one is become now 1, means we have to find half is still greater than 0, right? Then what we need to do, we have to apply this formula again. So res this time we'll do 1 2 3 2 into 10 plus 1, right? We can do. Now add all of this, what will come? 1 2 3 2 1, right? Now again you divide by 10, so 1 by 10 become what? 0, right? That is, we have completed this loop, and so the final result is 1 2 3 2 1, and we'll return this. Understand? I hope you understand this create palindrome method. Okay, so now understand this is mirror method, right? So how this is mirror method works, right? So what is the purpose of this is mirror method? So we want to check, right? To check if a number is palindrome, if the number is palindrome, right? In the k mirror numbers, right? If the number is k mirror number, you can say, right? If the number is k mirror number, then we can say a palindrome in base k as well as in the base 10, right? You know, if the number is in the base 10, right, we have seen that base 10, and also in the base k, right? Like we have seen that in the base 2, right? If both is in the number is in the palindrome in their number system, it means it is mirror will say true, right? And for that we have to write the number, we have to pass in the 2 base, and you will pass what? The base will return the string, and you will check the palindrome, and you have the separate method to check the palindrome, right? So that we will discuss later. Just understand now how the 2 base will work. Till now you understand? So our purpose is to convert the number, this number, into a base k using the 2 base, right? And we'll check if the base k string is palindrome using this is palindrome method. Understand? So for example, let's suppose in this case we will use what? This method will use here nums, will take nums what? As a 9, and k will use as a 2. Understand? In the very first step 1, what we will do, we'll pass in the step 1 and we'll do a step 2 here, right? Now step 1 will pass 2 base 2 what is the name? 2 base k, and we have to pass in this method what? Num is 9 and k is 2, correct? It means this will return what? You know that what we return 1001, and this is in the binary system 1001 we'll say, right? In the step 2 we have to say is it palindrome, so now we have to call is palindrome method, and we'll pass what? Base k 1001, 1001, right? We'll check if 1001 is palindrome or not. So we can see that this is palindrome, so it will return true. So if it is returned true, so is mirror will say Yes, it will return. And you know, after that what you need to do, we'll add this into the sum and we'll increment the count, right? Understand? We'll do count plus plus and we'll do the sum plus. We'll add this number into the sum, right? Now understand the base k, 2 base k. Okay, so this 2 base k method, what it will do, right? We have the num, it is in the long, and k in the integer as it is. We are not changing anything. Means to convert, our purpose is to convert the number from base 10, right, to base k, and then we'll return the string as we have seen, right? So we'll pass this number. Let's suppose the 9 we have passed, right? So you will pass 9. You have to take the mod, and then you will keep adding into where? Here, right? So you will get converted the number. You will keep dividing this number and you will get it. Let's suppose for example that we have taken what? The nums we have taken what? Is 2, 9 we have taken, right? And k we have taken is 2, right? We should take always in the example less small number so that you will understand. So very first step, when you will pass num is greater than 0, so 9 is greater than 0, right? It means in the very first step what we will do, we'll take the 9 mod 2, right? And it will give you what? 1. We have seen already, right? So it will give you 1, right? Then we will append this into our substring, and that is what? 1 we will get. Next time we know we will get 9 mod 2 will get what? 4. So we'll take 4 mod 2, and you know we have to divide the nums also, right? So we will divide the 9 by 4, 9 by k, that is 2 we are doing, right? We are dividing 9 by 2 we are doing. Then you will get this value and you will return it, right? So you will keep doing this until you get the number, right? So this time you will get what? 0. Then you will get 2 by this 2 will get what? 0 again. Then you will, you know, you will get 1 like this, and you will get 1 here, right? Means we have to append these numbers into here, right? And you will get what? 1 0 0 1, right? Like that you will get. Understand? So we don't need to reverse it back because we are checking palindrome, right? And the digit order is still reflect what we needed, right? Now you know the how to find the palindrome number, right? But still let me explain you, right, how this palindrome will work. Let's suppose the palindrome we have to check is 1001, right? That we have seen. This is string we have to check. So in the very first step, what we need to check? We will check 1001. Is it true? Yes, true. Then we'll check 110. Is it true? Right? False. It will give. Then we'll check what? 1221. Is it true? It will say true. Why? Because we have taken left and right. You know, the left is here and the right is here, right? We know the left is here, right is here. We'll check if this is equal. Now left will get increment to here and right will decrement it to here, right? It will keep checking. If both are not matching, right? If the character at left and character at is not matching, we'll return it. Let's suppose for this case, right? 1 1 0. When left is here and right is here, it is not matching. Just return false. If it is matching, let's suppose this is 1, right? So this and this is matching. We'll decrement it. Now the left and right is both at here, so it is also true, so we'll return true. I hope you understand, right? Just we need 2 pointer concept and then all done, right? So what we need to do in the very first step, we have to generate all the palindrome, right? And so we'll use this create palindrome method to build a full number like 1 2 3 2 1, or you can say we can take from the half 1 2 3 as we have understand. Then we'll take what is mirror method will check, and so this method will also pass what to base k method that we have seen, right? It will convert the decimal to the base case, right? And then we'll also check is mirror method will check what is mirror is not or yes or no, right? So base case will convert the decimal to the base k, and the palindrome will check if it is palindrome or not. So this main loop, this is the main loop where we will do everything, right? So the main loop will keep finding the next palindrome. in the base 10 and will keep checking in the base k, right? I hope you understand. If you understand the problem statement, please let me know the time complexity and space complexity in the code, right? If you're not able to figure out, let me know. I will make the comment and you will understand there. Thank you guys. Thank you for watching this video.